So welcome to National 5 Chemistry. This is Unit 3 and this is going to be another lesson on metals. Specifically, we're going to be looking at how to extract metals from ores. Metals are particularly useful, but most metals are not just found naturally lying around on the earth. They need to be extracted from rocks called ores. And when it comes to metals, the more reactive the metal, the harder it is to extract that metal from its ore. And so we're going to look at a few different ways in which metals can be extracted and be correlating the reactivity of the metal to the method needed to extract it from its ore. So there are going to be 4 ways in which we find metals or we obtain metals. The first is for very unreactive metals. Really, this is only gold, which can be found naturally. Then, for less reactive or unreactive metals, you can extract them from their ores just using heat. For reactive metals, they can be extracted using heat, but you also have to add in carbon, and that's going to do a reaction called a displacement reaction. And finally, for the very reactive metals, we need to extract them using a process called electrolysis, which uses electricity. So for naturally occurring metals, the really only example of this is gold. And gold is so unreactive that it can be found on its own in nature. So historically, one of the reasons why people in America ended up on the West Coast was the gold rush, where they kept following the rivers, looking for places in which they could find lumps of gold being washed down rivers. And they used to sieve out the gold and try and find it. And as a consequence of this, it was one of the reasons why America did become, a lot of people in America did become prosperous. Now, gold is only able to do this because of its unreactive nature. There are no other metals that you can sort of just find on their own. Second method is by heating a metal ore on its own, so using heat. Now this works for unreactive metals. So metals, by unreactive we mean can only react with things like oxygen. So the ones down at the bottom of a reactivity series. Now this is because the metal is not strongly bonded to the other elements in the ore, mostly oxygen, and so those bonds can be easily broken. Examples of metals that can be extracted from their ore using heat alone are silver and mercury. Now, how we can do this and show what's happening is if you take your metal ore or your metal oxide, which is a substitute for the ore, and if you heated it with a Bunsen burner in a test tube, like in this diagram, and you had a tube coming out of it, going into a tank of water, you would see that as you heated it up, you would get a gas being produced. So as the silver oxide is heated, the bonds between the silver and oxygen are broken, leaving behind molten silver. So you will see this black solid, silver oxide, grey solid, turning into silver, liquid silver metal, and you will see bubbles of gas being given off. So those bubbles of gas are oxygen. So you would see silver oxide producing silver and oxygen. That's the equation shown in green. And we could prove that that gas was oxygen by doing our test. And oxygen gas will relight a glowing splint. The next method for more reactive metals is to use heat, but to also add in carbon. So when you try to extract reactive metals, heat on its own will not work because the bonds between the metal and the other elements in the ore are just too strong for heat alone to work. What you add is carbon, and carbon will help to break the bonds between the metal and the other atoms. And examples of metals for which you can use heat and carbon are copper, lead, tin, iron, and zinc. So how you can do this is if you mix charcoal, which is a pure form of carbon, with your metal oxide and heat it over a Bunsen burner, You can sometimes see at the boundary between the metal oxide and the charcoal, you can see silverish metal form, or in the case of copper, you'll see that characteristic copper color forming, but that doesn't always appear so obvious. So sometimes what you can do is you can heat it up so that it's glowing red hot, and then you can take that test tube and plunge it into a beaker of cold water, which will shatter the test tube. And if you leave all of the contents to settle, you will see solid lumps of metal inside the water, and you can separate them that way. Now, what's happening is we are doing what's called a displacement reaction. Now, most metal ores are mainly metals reacted with oxygen. So when you add carbon to the metal ore and use heat, what happens is that the carbon displaces or steals the oxygen from the metal oxide to form carbon dioxide, and what gets left behind is the pure metal. So metal oxide plus carbon goes to metal plus carbon dioxide. So for example, iron oxide reacting with carbon forms iron and carbon dioxide. Zinc oxide reacting with carbon goes to zinc and carbon dioxide. So the products of an extraction using carbon are always metal and carbon dioxide. Now, the final method that we need to know about is electrolysis. Now, very reactive metals need a lot of energy to try and separate and break the bonds between the metal and the other elements in its ore. And one way of providing a lot of energy quite easily is to use electricity. And when we use electricity to split apart a compound, we call that electrolysis. So electro means electricity, lysis means splitting. So combined together, splitting using electricity. And on the list of metals in the page 10 of your data booklet, the ones that you need to use electrolysis to separate from their ores are aluminium, magnesium, sodium, calcium, potassium, and lithium, all the ones at the top. Essentially, on that list of metals, all of the ones that end in IUM. Now, what happens is usually you need to melt the metal oxide or dissolve it somehow. And then when you apply electricity to it, you will see you will use two electrodes. One electrode you will get oxygen gas being produced at, and the other electrode you will see the metal being formed. So this is a simplified diagram. In industry, the process looks a bit more complicated. Now, what is happening is the electricity is providing and taking away electrons, and we will learn about this in a future lesson. But during electrolysis, you will see oxygen gas being produced and the metal being produced. Now, for example, if we do electrolysis on magnesium oxide, where the metal is being formed, the metal ions are gaining electrons to form the metal. On the other electrode, the oxygen ions are losing electrons to form oxygen. Where electrons are being gained, we call that reduction, and where electrons are being lost, we call that oxidation. Together, we call this a redox process, reduction and oxidation simplified to redox. And as I said, that will be a future lesson. To summarize, we're going to go through the list of metals on page 10 of your data booklet and the ways in which they are either found or extracted from their ore. So starting at the bottom, gold is very unreactive and therefore can be found naturally. For silver, mercury, and sometimes copper, these are the less reactive metals. They can be extracted using just heat on its own. For the next set of metals, the reactive ones, so zinc, iron, nickel, tin, lead, and copper, the easiest way in which they are extracted is using heat and carbon. And then, as we said, the elements at the top, the metals at the top, All the ones on that list ending in IUM are very reactive and we need to use electrolysis. So that has been a summary of the ways in which metals can be found or extracted from their ores in order for us to then use them for a variety of purposes.